All right, so for this review, we're going to talk more about variables and then multiplying and dividing. The video before, we talked specifically about how to simplify radicals on their own and how to combine like radicals. Now we're talking about how to simplify when we have variables, as well as being able to multiply and divide our radicals together. So first things first, we have to talk about the steps of how to simplify variables in a radical. And our first thing we want to do is just separate everything. We want to give everything its own space, practicing that social distancing. And we want to put all terms in their own radical. Now, the next thing we'll have to do after we have separated everything is we want to make sure that we factor those numbers the same way we have been doing. We're still factoring the radicand. But then the tricky part comes with our variables. We want to be able to divide variable exponents by 2 because we're talking about the square root, and we said squaring has the number of 2, so our exponents are going to be divided by 2 to get their exponent for being outside of the radical. So we'll look at this example here in a second. But when we talk about separating, we're either going to just separate the variables as like x and y, or we might notice that 13 is not even, so it does not nicely divide by 2. So we're going to have to split that again just after we split up all of the variables. We'll talk about that. Now, the last thing we're going to do is we want to write our final answer, as the non-radicals first, as coefficients, and then everything else should be in a radical. So then radicals all as 1. So now we've talked through that. Let's take a look at what this next example here actually looks like. This square root of 25 x to the 6 y to the 13th. So like I said, we want to separate first. The first step is to separate. So we do square root of 25, square root of x to the 6th, and the square root of y to the 13th. Now, the square root of 25, you might notice and know that right off the bat, that is actually a perfect square. 25 is 5 squared, so instead we can just write this as 5. Now, we said for our variables, we want to be able to divide our exponents by 2. We want to divide by 2, so now we would take x to the 6 divide by 2. Now, once I write that divides by 2, I get rid of the square root sign. There is no more radical there. It is just x to the 6 divide by 2. Now, this y to the 13, though, gives us some trouble. As I said earlier, it's not an even number, so it doesn't divide by 2 evenly. So what we have to do is we have to separate it again. We're still separating all of our terms. So we would now have the square root of y to the 12th and the square root of y. And the reason we do that is because I want to have an exponent that is even and whatever is left. Since we're dealing with 2, every other exponent would work, and the way that we would get y to the 13th again is to combine these two together. We would be adding 1 more to the exponent. So we're just taking 1 away whenever we have a variable that's not even. Now, we would have our 5, and we know that when we have x to the 6 divided by 2, that becomes x to the 3rd. But now we have our y to the 12th divided by 2 because that's our even exponent. We can get rid of the square root, but we can't get rid of the square root around just y. So final step, we want to take our 5, x to the 3rd. This 12 divided by 2 becomes y to the 6th, and the square root of y. Now, I don't have anything else to order this with because it's already in the order that we want our final answer to be. So we have our coefficients, or everything outside of the radical, first, and then anything that would be in the square root would just go inside one square root. So if there were, let's say this was 3y, we would have square root of 3 square root of y. we would just combine that as the square root of 3y. So this is our final answer, though. For this one, we had nothing else to combine in there. Now, I said we're also going to talk about multiplying and dividing. So let's take a look at a couple of examples over here. For multiplying, we still want to be able to simplify our radicals if we can. And I notice off the bat we have a 10. And in the previous video, we talked about how 10 is an okay number to have because it's really small and it doesn't have a lot of factors. So we know that that number is going to work. But 12 isn't much bigger. However, it has a very specific set of factors. It is 1 and 12, 2 and 6, and 3 and 4. Now, you'll probably notice that this one is special because it has the number 4. 4 is a special number, and when we list the factors, we said previously we want a perfect square and a small, if not prime, number. And 3 is just that. It is prime. So we have the numbers we want, so we're going to write 5 square root of 10, because that can't be simplified, multiplied by -7, square root of 4, square root of 3, because we're going to write both in the square root. Now, square root of 4 is 2. So instead of just saying square root of 4, we can simplify this a little bit farther. We still have our 5 square root of 10 there. Now, -7 times 2 would give me a -14, and we still have our square root of 3 in there, and 5 square root of 10. Now, when we multiply these two things together, we've just been simplifying so far, I want to multiply my coefficients, my numbers out front together. Those two get multiplied together, so I get -14 times 5. And then I take my 10 and my 3. They're both in the square root, so they're both going to be in the square root still, but we're multiplying those two numbers together. Still the same idea. Now, when I take -14 times 5, I'm going to get -70. And then 10 times 3 gives me the square root of 30. Now, 30 is, again, a special number just like 10 was. 30 does not have any factors that are perfect squares. Its factors are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So none of its factors are perfect squares, so this is all the farther we needed to go. So multiplying, we're just multiplying the numbers together depending on if they're in front, or our coefficients, or if they are our radicands, if they are the numbers inside our square root. So let's move on to talking about divides here really quick. We have two different examples. We have one where we have the big square root, and we have one where there are two small square roots. You can approach these both similarly. You can either notice that maybe you can simplify something out of these two. However, 49 and 100 don't have any common factors, so we can't simplify 49 and 100 with anything. But what I do know is 49 and 100 are special numbers. They are both perfect squares. So if I separate my square root, and I make this the square root of 49 and the square root of 100, I know that the square root of 49 is 7, and I know that the square root of 100 is 10. Now, I can't simplify this any farther either. This is all the more I need to do for this first problem. For the second one, though, it's not one big square root. However, we can still do the same thing. We can still say, how many times does 12 go into 36? Well, we know that 12 goes into 36 3 times. So this would be the square root of 1 and the square root of 3. Well, the square root of 1 is 1, but 3 does not have a square root. So we need to do what's called rationalizing the denominator. We multiply both the top and bottom by the square root of 3. And we do that because we don't want to have a square root on the bottom or in the denominator. So we'll get 1 times the square root of 3 over square root. And we said when we multiply these things together, we do 3 times 3 in 1 square root. Well, 1 times anything is whatever you started with, so we have square root of 3 on top. 3 times 3 would give me the square root of 9, and we all know that the square root of 9 is 3. Therefore, our final answer for this one is square root of 3 over 3. Now I've got one more example to show you for this one. We want to find the area of a rectangle. And now when we find the area of a rectangle, we still want to leave it in the radical form. We don't want to use decimals. We still want it as a square root. So the first thing that I would do is I would look to simplify these two before I try and solve the actual problem, because that'll just make multiplying, adding, subtracting, all that will just be easier once I've done that. And so we said earlier the square root of 12 breaks down into 1 and 12, 2 and 6, and 3 and 4. We know 4 is the perfect square and 3 is the prime. So we'll have 5 square root of 4 square root of 3. The square root of 4 is 2. So we take 5 times 2 and the square root of 3. We get 10 square root of 3. Now for the other side, 243 is a little bit of a larger number. However, it is a little bit of a trickier looking number than it actually is. So if we list the factors for 243, we have 1 and 243. 2 doesn't work because it's not an even number. However, 3 does. It's 3 and 81. Now, I don't need to go any farther because we've said 3 is a prime number and 81 is actually the square of 9. So 9 squared would give me 81. So I would write this as 4 times the square root of 81 times the square root of 3. Now, the square root of 81, I said, is 9. And 4 times 9 would give me 36 and the square root of 3. So we've reduced our sides down, but we want to find the area. We're not just looking for perimeter or just looking to simplify those down. We're looking for the area. And to find area, we take length times width. Base times height, however you want to think of that. Both are the same. So I'm going to take 10 square root of 3 and multiply that by 36 square root of 3. Now this is where it's nicer to simplify first, because 10 times 36 would give me 360. And 3 times 3, both in the square root, would give me the square root of 3 times 3. In other words, I have 360 times the square root of 9, which is 360 times 3, because we know 9 is a perfect square. And when I multiply those two things together, my final answer is 1080. Now, I don't know what the units were for this, so I would just say that this is units squared. We want to make sure that we are following the context of the problem. We're not just multiplying two radicals together. We are finding the area of a rectangle. Now, this has been the reviews for square roots, how to simplify radicals. If you have more questions on any of this, just let me know. You can